Hello everyone, my name is Djura. I'm Associate Professor of Structural Engineering at IOSS Pavia in Italy, or better known as the Rose School worldwide. Today we're going to look at the hazard module, and it's specific the hazard consistency application that we've developed as part of the Djura online platform, okay? So we can go over here, we can see within the hazard module, we can see we have two different applications here. We have the record selector, which we have seen in previous videos. So how to select ground motion records using different approaches. If we click into that real quick, we can see we have different approaches in here that we talked about in different videos. But what we're going to talk about today is the hazard consistency. So before we use this, we're assuming that you're already familiar with the basics of ground motion record selection, and you have a set of ground motions that you wish to check the hazard consistency of them. And if you're not, you can go and check out the conditional and unconditional selection and the also the code-based selection methods, which we've put on the other module I just showed you a second ago. And we have some blog posts as well and some descriptions on our website, which can help you out to understand what these are all about and how you can use them. So in the simplest form, what we're trying to do here is we're trying to verify the consistency of the hazard, the implied hazard of the ground motions that we have, with the actual results we get from our probabilistic seismic hazard analysis, so the PSHA results, okay? So when we have this set of ground motions, we want to be sure that these actually do reflect the actual seismic hazard of the site that we see from something like a PSHA. So what this means is that even though we're selecting our ground motions according to a target, a conditional intensity measure, we also have different kinds of intensity measures. So let's say the spectral acceleration at a different period other than the one that we conditioned at. Is the implied hazard of that going to be matching to what we see from a PSHA, or is it going to be something different? The same thing as well, we can do this with duration, we can do this also with velocity and so on and so forth. We'll just look at spectral acceleration here as well, but in principle the same thing is possible with all IMs that we're going to see that we've seen in previous videos, but we'll just look at the SA based ones. So what the video is going to do is essentially it's going to back calculate the hazard of the ground motions that we have, and hopefully these are going to line up with what we see. So it's going to compute the implied hazard of these, okay? And this should hopefully give us a set of ground motions which do in fact represent the site hazard because they match the probabilistic seismic hazard analysis results we had before. So this is quite important when we're looking at risk assessment, because if we don't have hazard consistent ground motions, it can lead to problems when we have risk estimates at different periods and so on. We have different papers and we can there's a lot of work in the literature talking about this, but actually ensuring this hazard consistency is something that is not dealt with a whole lot. So using a tool like this, it's something you can check very quickly and demonstrate that your ground motions were in fact hazard consistent. So by default, the results you're getting from a structural analysis should be in a relatively good position to give you accurate risk estimates. So if we look at this module, we can see in the screen right now, there's a little description we can see right here. We have some action buttons we have over here on the right hand side, but we're going to look at the inputs that we need. The inputs are actually quite simple because it's really just the results of different sets of analysis. Because really what we're doing here is we're comparing a ground motion record set, so many different return period sets of ground motions, to the overall PSHA we're interested in. Okay, so we're comparing PSHA results to ground motion record selection results. And this is going to be inputted in the form of a JSON file. Okay, so we have a download sample here. You can see what we mean, and there's some sample results we'll look at in just a second. Or you can go ahead and this is what you will do. You'll upload your own JSON file of your own results in this format we'll see in just a second right now, and you can just quickly evaluate all of this with the tool we've developed right here. We haven't implemented it just yet, so but it's currently underway. So you can actually just go and connect this to your local folder as well. So you can have your root folder. So this is maybe somewhere on your own local machine, and you can have a certain structure of folders in this kind of way. So let's say the structure of the ground motion records, you have the names of those, the time steps, the folder of the names, the actual records themselves. And this will all be a subset within this folder, the probability of exceedance and a certain value in something years. And this can greatly help you out by linking your actual ground motion record selection results to the tool we're using right here today. Okay, and there's some description here as well. So the POE value, we can say something like 1%, so 0.01, the year value. So this could be something like 1% in 50 years, and so on and so forth. Okay. But we're going to use the one on the left hand side because this is the one we have up and running right now. That works pretty well. So we can say we can upload our JSON file. We'll do that in just a second, but let's look at the inputs right here. There's let's say a mock structure of the file right here, and maybe it looks a bit intimidating, but it's actually quite simple. So if we think about it, what we're really doing is we're looking at the record selected results and we're looking at the PSHA values. So you can see here the different variables we have within this JSON file. We have RS something, and we also have PSHA something. So anything with RS means that these are the record selected results, so the IMIs, the non-conditioned periods basically. So the ones, the IM star would have been the conditioning period, or the conditioning intensity measure. So these are the periods associated with the non-conditioned intensity measures, and also the intensity values. With the examples down here, there's a little description below. And here it's giving you some description of what they should be. They should be arrays of a certain size. And also in the case of the PSHA, we're looking at the IM star, so we're looking at the conditioning intensity measure. We're looking at the intensities of those, the probability of exceedances, and also the non-conditional intensity measures, the IMIs, the intensities of those, and also the probabilities of exceedances. There's some string values here as well with the X label and the Y label that you want to show up in the charts that we'll see in just a second. That can help you out with if you want to save these figures and use them quite quickly. You can change these yourself and just input this information directly. So we can see this information here. We can see right down, we have the RS-IMI periods. We can see this is going to be a list of length, the number of the IMI periods from the record selector, and so on and so forth. The IMI intensities is going to be an array of dimensions. It's going to have the number of PSHA IM star intensities by the number of records, by the number of IMI periods. So this is going to be a three-dimensional array of quite a lot of data. It seems quite complicated, but when you organize your data and just format it into the right dimensions, it's actually quite easy to implement. So what we'll see here is we're going to just look at a download sample file. So I've already downloaded this file here. You can download it again. Okay, so we can download, we're just going to select it here, and we'll download this onto our local machine. So you can go ahead and check out that sample JSON file, but we're just going to re-upload it directly, and we're going to check out what these results look like on our evaluation, basically. So we can check the input. We can see the input file has been validated successfully. So what this is doing is going to check all the dimensions of these arrays. So obviously the file that I've uploaded is going to be okay because this is something we created as an example to get you all going with this. But let's say you create your own file. You can quickly check all the dimensions that all of these arrays do actually make sense. You've inputted the right amount of information, because there's a lot of stuff from both the record selector and PSHA to implement here. So we can see everything is fine. We can go ahead and we can verify the hazard consistency and just click on that button. We'll scroll down to the bottom and we can see the results are showing here. Okay. Now there's a couple of things to look at. And the first thing we're going to do is we're going to look at the left-hand side. Okay. So we can see the axis labels. These are something that are specified in the JSON file. So just spectral acceleration versus period, for example. And we can see we have a number of sets of ground motions and also the conditioning IM. Okay. So what this is basically saying we have, I think there are 10 or a certain level of 1, 2, 3, 4, 5, 6, 8, yeah, probably 10 sets of ground motions here. So what happened here was we have a conditioning period of 0.7 seconds. And for every single of one of these 10 return periods, we did a conditional selection with something like 20, 30 ground motions here. So if I turn off all of these different layers here, I can eventually break this down and we can see just a single selection in, right here. Okay, we can turn off the conditioning IM. So what we can see here is we've got a single set of ground motions. Okay, they've clearly been conditioned by just looking at them to the to 0.7 seconds, and they have a certain distribution away from the conditioning period here. And if I turn on a different set here, I can see I have another set. Okay, the line, this line coloring is automated as well to make them different and make it easy to visualize. But we keep adding more in here. We can see we have another set of ground motions here at a slightly lower intensity, slightly lower again, and so on and so forth. Okay, so these are all different sets of ground motions. We're just plugging them all together here. And if we compare these to the conditioning IM, so this is what we had from our PSHA, we can see that already by just looking at the conditioning intensities, by zooming in right here, we can see the conditioning, the pinch value of any one of these sets of ground motions does actually correspond to a conditioning IM for each one of those return periods we're looking at. So already we can see that at the conditioning IM, they are relatively consistent with the actual hazard. But what we're interested in here is we want to look at what about periods away from the conditioning period. So if we let's say we zoom this out again, and we want to look at just between 1 second and something around 0.5 seconds. So we can zoom in a bit here, and we can see that sure, at the pinching value of 0.7 seconds, they tend to match up with the conditioning IM. Fine, that makes sense. We selected the ground motions according to that IM. But what about something like 0.5 seconds somewhere over here? And what about something like 1 second at a value over here? So are these ground motions going to be consistent with what the PSHA was telling us at these periods, or these other IMIs in this case is what the terminology is? So this is what this tool is doing. It's integrating all of this information together and try to compare them to the PSHA. And this is what we can see over on the right hand side here in this second figure. So this is the real output we have from this tool. And what we can see is the dashed lines are the PSHA results, so the hazard curves that you get from your PSHA, and the solid lines are ones that have been back calculated from this ground motion set that's shown on the left hand side. So this is the back calculated hazard associated with those ground motion sets. And what we're looking for here is the matching between both the solid and the dashed lines, which we can see already that they look pretty good, okay? So we'll zoom in first to the case of 0.7 seconds. So this is the conditioning value, so we're expecting these to be quite well matched, so we can zoom in here, okay? And we can see that the dashed line is relatively smooth because this is coming from probabilistic seismic hazard analysis. And the solid line is the one that's being back calculated from the left-hand side, and we can see it's matching pretty well, okay? It's not a smooth line because we have a limited number of ground motions and also return periods, but if we added more of those, we would get a much smoother line as well. And also there's some fitting errors that are just part of the process too. But overall, we can see the matching between those two curves is very, very good. So we can be relatively happy that the hazard consistency at a spectral acceleration of 0.7 seconds has been achieved because of the graph we see on the right hand side. But also we can see this on the left hand side because the actual conditioning value is matching up with the one we have from the pinching point of the ground motions. So that's the first point. So let's just zoom out again, and we can look at another set of IMIs here. So we can go into a different window. Oops, let's go back here, and let's zoom in for another set of these. Okay, so let's look at the case of the pink line here. So we can see this is for the period of 1 second. We can see that in the legend right here. So what this is saying is it's saying that, okay, but what's the implied hazard of the ground motions? The entire set of ground motions, so all of these lines I have here, so there are quite a lot of lines. You can see from the legend, it gets a bit crazy, but this is just because of the amount of information that's being plotted. What's the implied hazard of that set of ground motions with the associated return periods? So if I back calculate the hazard with those, what is the implied hazard at that period of vibration, so at SA 1 second? And it's essentially this solid line we have here. And comparing that to the PSHA we had, which is the dash line, we can see that at 1 second, this ground motion record set is actually hazard consistent, okay? So it's matching the hazard, the implied hazard of the ground motions is matching the PSHA results. So we can be pretty happy with the results we have here and also at the other return periods. Getting a perfect match is not something that's easy because of fitting errors, because of limited amount of return periods and so on and so forth, and a whole other reasons that we'll talk about in the blog. But we can see on an overall basis that the matching between the implied hazard of the ground motions and the actual PSHA results is relatively good, okay? So we can go ahead and we could look at the tabulated data here, or we can close that view if we want, or we can also just go and restore the plot back to its default value. Okay, that's something we had seen before. Let's zoom in right here. Or we can go ahead and download this as a figure to use directly in our results, just to show that yes, in fact, the results are in fact hazard consistent. So why does all this matter? So if we're using ground motion records in our nonlinear analysis, so let's say doing a risk assessment of a structure, and we have our ground motions to do our analysis, we want to be sure that at all of the different intensity measures of interest, so maybe at different periods of vibration, that the ground motion records are actually consistent with the hazard. So when we're doing something as simple as conditioning on just the SAT, so this could be the first mode period of the structure, doing something like matching all to the pinching point could be a relatively good way of doing it, but also you may be concerned with what's happening at other periods of vibration. And by doing a check like this, you can demonstrate that your ground motions were actually reflective of the site hazard. So there are plenty of studies as well in the literature showing the importance of this and showing actually how this is calculated. I'm just showing the application here, but I'm not showing the actual theory of it. For that, you can find different resources as well that explain this. But the implications of this are basically, if you're doing risk assessment, not having hazard consistent ground motions can be quite problematic because of the inconsistency of the the risk estimates that you obtain from your analysis. But if you can show something like this, you can avoid a lot of those problems and get much more accurate results. So once you're finished with this, you can go and download all of these. You can download the figures directly. You can download all of the data and the verification results and have these on your local machine and plot these. You can also set this up as an API. So this is, like we've mentioned in previous videos, this is just a demonstration of how this tool works. If you have your API set up in something like Python, you can directly query this, the Djura platform without going through the user interface like I'm showing here. Once you have this JSON file set up, you can just directly ping it into the system with the API and get the results and get some plots like this directly back out without ever having to log in and do any of this visual comparisons, okay? So this post was describing the hazard consistency and why we need to do it. and the kind of verifications that we can do with a tool like this, okay, and which is available here on the platform we've developed at Djura. So we've tested this, and we're adding more features as well and flexibility. So if you've got any specific requests, just let us know, okay. And if you have any suggestions, get in touch with us. We'll be happy to implement them. This is just a starting point that can hopefully get you moving with your hazard consistency checks. Like I mentioned, we've got the API as well. If you want to implement this with your workflow, it's all possible. If you're not sure how to do that, get in touch. We can help you out that as well. So it's just one of the applications we have. Get in touch as well if you want to use the service. It's the website. Drop us an email. Get in touch. And yeah, stay in tune for other videos and contact us as well if you want any more information on this.